Welcome back there, Algebra 2. Today we're looking at lesson 22. We're going to analyze some graphs. We're going to look at continuous, discontinuous, and discrete functions. So our goal today is to identify domain and range, and we're going to look at how we write out domain and range to represent that, and then learn to identify different types of functions. So buckle up, here we go. First couple new concepts. A continuous function is a function that has a single unbroken curve. So if we have a xy axis, a continuous function is when you don't ever have to lift up your pencil when you are creating that function. So that would be an example of a continuous function. A discontinuous function is when we have a hole or a jump or a vertical asymptote where the function heads up or down to infinity. So an example of a discontinuous might be if our function starts heading up this way, and then there's a gap, so we got a little stop right there, which we can use an open circle to represent that, a little gap, and then it continues. So kind of skips that point, and we have a little point there where it is discontinuous. Another example could be our curve starts to come towards the y-axis, and then it starts to head down, and then our next curve is coming up, heading that direction. So we have this point on the y-axis where the graph is jumping from one graph to the other, and that's going to cause us to have a little bit of a hole or a jump in our graph. So in short, anytime you have to lift your pencil to continue to complete your graph, that is going to be a discontinuous graph. Finally, a discrete graph is a function with distinct separate values. So if we're talking about if you were starting a new workout plan and you were keeping track of your total number of push-ups each day, and each of those numbers would be a separate value, you would not keep track if you did half of a push-up or 3/4 of a push-up. You would just keep track of those distinct separate values. And we'll notice on a discrete function on a graph that those points are going to be separate, and we are not connecting them with a line because they do not represent a continuous value. So you're doing your push-ups on the first day, there's your tally. Second day is getting a little less. Third day you're a little less. Fourth day is less, but then you start to increase. You're keeping track of those separate values. In example 1, we're going to graph a discrete function and then a continuous function, and for both we're going to find the domain and the range. So really quick on the domain are representing the x values that are being used in the function, and the range is representing the y values that are being used in the function. In a discrete situation, we are just going to list the domain and range values, and you'll see in a continuous function we will give a span of x and y values that are being used. So we'll take a look at that in just a second. So I'll start out by finding the domain. I'm just going to look and I'm going to tally up all the x values that I'm using in my function and list those out in my domain. Then I'll take the list of the y values and list those in my range. Once I've got both my domain and range listed, I can now start to plot out the points. So I will take -7, 1, we'll go -7, 1, we'll start to plot out our points. So you can go ahead and plot out the other three. And once we have them plotted, they are discrete, so they are separate values. We will not connect those with a line. So we are just talking about separate, distinct values. We're not talking about any of the values in between, so we just leave our graph like so. Our second function, we'll graph it out. We've got g of x equals -2x plus 4, and don't be fooled by g of x. That just represents y equals -2x plus 4. So we've got a linear equation. So there's our slope, and there's our y-intercept. So we'll go up to 4, 1, 2, 3, 4. And then we'll graph our slope going down 2 over 1. So I'm thinking of that -2 as a fraction, -2 over 1. Now since this is continuous, we will connect it with a line. So we are going to represent all those solutions, those x and y's that are between those points as well. Now to start finding my domain and range, so remember domain are the x values that are being used in the function. So I'm using an x value of -1. I'm also using x values in between those points right there. I'm using an x value of 0, 1, 2, so on. I'm going all the way from negative infinity to positive infinity with my x values. So I'm going to say my x values are negative infinity. X is greater than or equal to that, but x is less than or equal to positive infinity. So that represents the total span of x coordinates that I'm using in this function. So since the arrows keep going on forever, that domain uses the whole span of x values from negative infinity all the way up to positive infinity. As I look at my y's, I'm using this y coordinate of 6, but then I'm also using y coordinates higher. As this line would increase, I'm still using y coordinates in the positive direction. And then I'm also using y coordinates of 4, 2, 0, -2, -4, and then those would continue to negative infinity. So the span of y's that I'm using is also going to be negative infinity is less than or equal to y is less than or equal to infinity. So we are not going to list out all of the x and y coordinates that we're using for the domain and range, because that would just take too long. That'd be an infinite amounts of points, and I don't want to sit around and write that out. So I am going to just give that span using inequalities to show that my domain and range go from negative infinity to infinity. So with a line like this, we have infinite amounts of solutions and then all those points in the problem. Our next step in our journey looking at these functions is going to be to identify a point of discontinuity. A point of discontinuity is the x value of a point at a hole, a jump, or an asymptote in a function's graph. So we're going to look for a point of discontinuity in just a second. So in example 2, we're going to determine if each graph is continuous, discontinuous, or discrete, and if the function is discontinuous, then name the x values where the discontinuity occurs. So as I trace this first one, again, I'm just going to use that simple pencil test. Do I ever have to jump or lift my pencil in the graph? For this one, no. So this one's going to be continuous. I'm just going to abbreviate that CONT. Next, I'm tracing my graph. Do I ever have to lift it up? Right here, yes, I've got a hole. I had to lift up to make that hole, and then I can continue to make my graph. So I look at where is that x value. It's right between 4 and 8. So here I have a discontinuous graph, and it occurs at x equals 6 because that's the number right between 4 and 8 on my graph. So remember that point of discontinuity could look like a hole. Like we looked at on the previous page, it can be like a jump in the graph where it jumps to a different point on the graph, or it could be a asymptote, which we'll start to see more and more as the year goes on. Lastly, we've got disconnected graphs. So this one is just simply discrete. So there's nothing else, no points of discontinuity. We just have a discrete function. Lastly, we'll practice determining if we're continuous, discontinuous, or discrete, and then determine if it's a function. We'll use our vertical line test, and then lastly, we'll determine the domain and range of each. So first, the continuous, discontinuous. So we're going to check, do I ever have to lift my pencil as I create that graph? Nope, so that is going to be continuous. Next, I can look at, does it pass the vertical line test? So when I think of a vertical line passing through, which I don't have a tool or anything for a vertical line, but as a vertical line passes through, it's always hitting one point. So that second question, is it a function? Yes, it's a function. Lastly is the domain and the range. So looking at the domain is the x values that are being used in the function. So the x values, I'm just kind of looking up how they line up with the x-axis. Like I'm using an x value of -1 right there at that point, an x value of 6 at that point, an x value of looks like 2 at that point. I messed up here. This would be an x value of 0, x value of 2, x value of 4, x value of 6. So we're using all those x values, and then as the parabola continues to go positive, continues to go negative, we're using all the x values from positive infinity down to negative infinity. So our domain is going to be negative infinity to positive infinity. But our range, as we look at the y values that are being used, I've got a y value of 10 up here. I've got a y value of 8, 6, 4, 2. Then over here, I've got a y value of 4 being used, a y value of 6 being used, a y value of 8. But as I look, it cuts off. It's never going below 2. I'm not using any y values, so the graph does not go anything below 2. So my range is y has to stay greater than or equal to 2 because it's not using any of those y values below that point of 2. As I check my second function, I go and look. I have to lift my pencil here to create a hole, lift my pencil here to create a hole, lift my pencil here to create a hole. So I do have a discontinuous graph. Next, I check the vertical line test. It's always only hitting 1 point. So yes, this one is a function. It doesn't ask us to find the points of discontinuity, but my points of discontinuity would be at -3, +1, +5. So I'm just looking at those x values of the point of discontinuity. We look at our domain. Our x values are going to continue go to -infinity. Along the x-axis this way goes to +infinity. So our domain is the same as the last problem, -infinity. Less than or equal to x is less than or equal to +infinity. And lastly, our range on this one, we have a y value of 3 to 0 being used all the way down. Once we get to -3, though, we are not using anything below that. So y is going to be greater than or equal to -3. So there would be our range for that one. Lastly, we've got a disconnected graph. This one is going to be discrete. Then we look at, does it pass the vertical line test? Yes, that's going to be a function. Then since we have these disconnected points, our domain is only going to be representative of those x values that are being used in the points. I'm not using any of the x values in between, so I'm not going to show a span of x values. I am only going to show the exact x values that are being used. So since my graph is counting by 2's, each square represents 2, so that's -2 for my x, 1 for my x, 5 for my x, and then 9 for my x. Next, we can look at the range as the y values being used. I'm using an 8 on that point. I'm using a 6 on that point. I'm using a 4 on that point, and I'm using a 3 on that last point. So there would represent my range. And also we can tell this is a function because none of those x values repeat. They each have their own y value. So again, that would be a function. So that kind of wraps up our introduction to discontinuous, continuous, and discrete functions. We'll continue to look at these graphs throughout the year. We will start to see special functions that do produce these special cases, but most of the time we'll see those continuous functions, and we'll start practicing even more finding the domains and the range of those. All right, thanks for joining. We'll see you next time.